Hello, let's do the New York Times Hard Sudoku for March 5th, 2024. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, I'm noticing this middle column is almost full, so let's just at least think about what it needs before we do anything else. We need a 1, which goes down here, one of these two, in this column. We have the 2, 3, 4. We need a 5. So, okay, this can't be 5. And then we need a 7 and a 9. Okay, this can't be 7 or 9. So this is down to 1, 5. This can't be 1, 5. So this is down to 7, 9. This is 5, 7, 9. Yeah, these are all worth marking. This is 5, 7, 9. This is 1, 7, 9. Okay. No singles or anything or like hiddens, but I think that's good to know. Let's go to normal scanning now. So these two 1s look to the right. This 1 looks up. So there's a 1, and the 1 in this box is placed right there. It's the only place for it, so it must go there. We have these two 2s that do the same thing. 2 in this box can only go here, so it must. The rest of this row, what do we need? We need a 4, 7, 8, 9. You know, I don't think that's worth marking. I mean, I see this 9 here, but that's it, and this 7. So let's hold off on that. What else is happening here? So the 6, the 1, the 2 are... I was looking to see if there's anything looking at these cells. Let's just see what these are. Actually, I've noticed that this 3, 7 is looking in, and we need the 3, 7 in the box. So there are only 2 cells that can have 3, 7 in this box, these two. And we need 2 cells for 2 values, kind of like how we needed 1 cell for the 2 and 1 cell for the 1. We need 2 cells for the 3 and 7. We don't know what order they go in, but they're going to end up here. And if they end up here, then nothing else ends up there because they're going to use up both cells. And that leaves, that's called a hidden pair, and that leaves a pair left over here. 4 and 8 is remaining. It's not resolved, but this 4, 8 pair is useful because it affects the rest of the column. Because 4 and 8 end up here, because that's the only values these two cells can be. And so in order to use 2 values in 2 cells, it's kind of the opposite logic here. We've got 2 cells, we need to put 2 values in them. 4 and 8 are the only options. So 4 and 8 are going to end up in here in some order, which means the rest of the column is not 4 or 8. So we can think about what's left, specifically 1, 5, 6, and 9. The 5 can't go in one of these two, so 5 ends up down here. I said 1, 5, 6, 9. Unfortunately, I don't see anything else going on with that. So that's a bit of a bust, but that's all right. Worth thinking about regardless. Always want to follow up on any new information you get, so you can really speed up your solve sometimes. If you miss that, coming back to it later can be much tougher. Did I get anything else out of this? And I think the answer is no. So let's move on to the next band here. I am noticing this 1, 3 looking into this box. Unfortunately, there's 3 places. Well, there's 2 places for the 1. We can mark that with corner marks. But in general, there are 3 places for the 1, 3. Or we're actually... Oh, no, sorry. We have both 1, 3s looking in. I missed this 3 sitting here in the corner here. Already in the corner, so I don't get a doot for it. Same exact deal here. 1 and 3 need to go in this box somewhere. There are only 2 cells that can have 1, 3. So those 2 cells do have 1, 3. The remaining 4 cells in the box, maybe useful, maybe not, will be 2, 5, 6, and 8. Well, the 5 is looking in, and importantly, this can't be a 5 anymore because of our hidden 1, 3 pair. Before we found that 1, 3 pair, we would have thought 5 could be in these 3 cells, but because it can't be here anymore, it's limited to these 2 cells. And because it is limited to 2 cells that line up, it does something called pointing, where the rest of this column cannot be a 5, because we already know where the 5 is in the column, kind of. We know it's in one of these 2 cells. It's going to end up here, or it's going to end up here. Those are our 2 choices. Either way, we can't put another 5 outside of those 2 options. Additionally, this 5 is looking into this box, and so there's only one place in this box for 5. It's right here. That leaves us with a 7, 9 naked pair here. Now, we could think about this another way, and I'll show you both ways. But with a naked pair, the logic is similar to this 4, 8. This 4, 8 was kind of a naked pair, but this is a true naked pair here. So basically what we've done is we've limited this cell and this cell independently. We've limited them to only 7 and 9. They see all the other digits. So just a 7 or 9 is going to end up in them. And we know it's either going to be 7, like it's going to be either a 7 here with a 9 here or a 7 here with a 9 here. Those are our two options. And so because of that naked pair, we basically know where the 7 and 9 are in this column and in this box. They're here. They're not anywhere else. We can't put them twice. So why would we still think that this could be a 7 or a 9? Well, it can't. If I try to put a 7 here, these are both 9. If I try to put a 9 here, these are both 7. So that's no good. These aren't actually 7 or 9. And that leaves a naked single 1. This cell has only one option left. If I don't make it that option, it has no value, and that breaks Sudoku rules. Every cell has a value. So that ends up a 1. That makes this a 3 and a 1 for similar reasons, and that makes this a 5. And that a 5. Now, if I backtrack, the other way we could have seen this was in this column, we have to place a 5, and now there's only one place left a 5 could go. So we can place the 5 there. And now in this column, there's only one place left we can place a 1 because this 5 occupied the other spot. And so our corner mark actually for this box is telling us that too, that this is the only place left for 1. And we still get this 3 and 1. We still get this 5. So 2 ways to look at the same thing. There's always going to be those 2 ways to look at it. Always. Because they're equivalent techniques looked at kind of in the inverse. And the results are going to be the same as well. But don't forget that this 7-9 pair also affects the rest of this box. We can't put 7s and 9s in the rest of the box either. So may or may not be useful. It does mean that this cell can't be 7 or 9, and the row still needs another 7 or 9. And so this is down to only 2 potential values. It can't be 1, 2, 3. It can't be 5, 6, and it can't be 7, 9. So the only 2 values that I didn't name are 4 and 8. So that's what's left for that cell. These also can't be 7, 9, and the row needs a 7 and 9 still. So these are also no longer 7, 9, might be worth marking. They can't be 1, 2. They could be 3, 4. They can't be 5. They could be 6. At least this one on the right can be 6. They can't be 7, 9 because of the 7-9 pair. And they could be 8. So I don't know if that was worth marking. But I'm going to leave it for now. Leaving this for now, might delete later. Anyway, what was I doing? I was kind of doing, let's follow up on all these digits we got. First thing I see is we have these 2 1s looking over. This one looks down. So there's a 1 placed there. I also see these 2, actually we have all 3 5s, so never mind. That's not helpful. I was just trying to follow up on all the digits we got. We did get these 2 3s. That puts a 3 in one of these 2 cells. And you might have figured this out by now, but if not, you might be confused about my 2 notations. I'm using corner marks to designate that within a box, those are the cells that remain for that digit. So 3 can only go in these 2 cells. We use corner marks for that. 5 can only go in these 2 cells. We use corner marks for that. We're using the center marks to designate what a specific cell has been limited down to, either naturally by seeing digits like the 1 and the 6 and the 5 here, or a little bit unnaturally like having the 7-9 pair remove 7-9 from these 2. It helps us track that. One of the most powerful ways of using notation is to track things that you found previously that might not be easy to remember later. And that's what writing it down is for. Anyway, there's 3 digits left in this row to find. We need to find the 2. We need to find the 4 and the 8. 2, 4, 8. This one's not 2, so this is down to 4, 8. This one's not 4, so this is down to 2, 8. And I think this is not 8, so this is down to 2, 4. You'll see this a lot where it's like 2 distinct digits in a set of 3 that they're not going to resolve themselves, but once one of them resolves, the rest of them do in a cascade. So what's the rest of this box? There are 3 digits we haven't found in this box yet. We need to find the 2, the 6, and the 8. But 2, 6, and 8. I'm not seeing anything. I was seeing this 2 here, so this is down to 6. Sorry, down to 6, 8. And this is down to 2, 6, 8. But notice that the 2 isn't here. So the 2 ends up in one of these 2 in this box. You can kind of just see that. And so those 2s, those also point. These can't be 2 anymore. Because if they were, there'd be nowhere to put 2 in this box, right? The 2 ends up in here or here. There's only 2 worlds. The 2 is here or the 2 is here. So it's definitely not here. Because that would, no matter where this ends up, these end up not 2. This 2 looks down. These aren't 2s. So 2 ends up in this 2 season here, right? So 2 ends up in one of these 2, which we can corner mark. I'm also just going to look at at least this column and this column, because they're down to 4 open cells. Whenever a row column box is down to 4, I always like to just think about, at least, if not mark, what the remaining digits are, because sometimes you can find things like hidden singles, naked singles, or hidden pairs, things like that. naked pairs pretty easily. Happens a lot because there's only 4 digits left. So anyway, the digits left here are 2, 4, 8, 9. And I'm just scanning around for 2, 4, 8, 9. So we know this can't be the 2. And that can't be the 2. We have that marked already. So 4, 8, 9. I'm really not seeing any use to that. I mean, this 4 looks in, this 4 looks in. That's not really good enough. Okay, so what about this column then? We need a 3, 5, 6, 8. No, we don't need a 3. I was about to say a lot of things see a 3, but they all see a 3. So I said that wrong. 1, 2, 3, 4, 5. We need 5, 6, 7, 8. 5, 6, 7, 8. So this cell can't be 5 or 6. So we can just mark that as a 7, 8. None of these see any of 5, 6, 7, 8. So that's a bust. Okay. It seems like this row is quite limited. It is down to 4. We are down to... I can really just read the digits that are left here as 4, 7, 8, 9. So 4, 7, 8, 9. It's not a 7, so let's put 4, 8, 9 here. Be done with it. All right. All right. I have not really finished scanning. I've really only scanned this band and a bunch of tertiary stuff that I happen to see. So let's just keep scanning. Like we've got these 2 3s looking in. We've got this 3 looking down. So 3's in one of these 2 cells. And I really like seeding the board with these corner marks at the start, although this is not the start of the puzzle anymore, but it's because I've been taking my time here explaining things. But I do like to corner mark things and seed the puzzle from the start, because as soon as we start, it really can help with the cascade of information that you get, of just finding all the hidden singles and boxes once they start getting eliminated. There's also a few other things you can do with them, but those are the only repeats here. We have a lot of open houses, like houses with, or not open houses with, a house being a row, column, or box. That's just a generic term for all 3. We have a lot with only 4 possible digits left in this puzzle, it seems like. So we have the 1, 2, 3. We need 4, 5, 8, and 9. So this can't be 5 or 9. So this is down to 4, 8. We've got a lot of 4, 8s going on here. 4, 5, 8, 9. These aren't 4. I was really hoping this couldn't be 4, but it can be. So these are down to 5, 8, 9. And this is any of them, it looks like. Oh, it's not 5, actually. So this is 4, 8, 9. Okay. That wasn't as fruitful as I hoped. I don't think there's anything else to scan horizontally here. I'm looking just real quick. Mostly at 1s. Because this one can't be in these, and then these 2 ones look down. In fact, these 2 ones looking down, that's actually really important. So in this box, 1 is in one of these 2. We can just leave that as a corner mark. But if we notice that the 1 and the 5 both ended up corner marked in the same 2 cells, and only those 2 cells, what we have discovered is a hidden pair, just like this 4, 8 that we found, or actually the 3, 7 that we found, and this 7, 9 that we found. If you remember that, maybe it wasn't the 7, 9. Maybe it was something else. Anyway, the hidden pair, it's because the 1 and the 5 both want to be in these 2 cells and nowhere else. So that's where they get to be, because we need 2 cells for those 2 values. So that ends up a 1, 5 pair. And then this is going to end up a pair as a result, because we've got the 1, 5 pair and the 4, 8 pair. There's going to be 2 other numbers that need 2 cells, and they're going to end up here. So we have the 1, 2, 3, 4, 5, 7, and 8 basically accounted for. So 6 and 9 are left. Nice. Okay. So there are 4 cells left again. Lots of times with 4 cells left, just in the middle of doing stuff. But we need a 2, 4, 7, and 8. This 4 looks in, so these are down to 2, 7, 8. Oh. I didn't notice the 4 and the 8, so let's start over. This 4 and this 8 look into this box. So we could, again, corner mark 4 and 8 here. But if we notice, they overlap. 2 corner marks overlapping in the same 2 cells and no other cells. They don't exist outside of those cells. That is a hidden 4, 8 pair. Very nice. And so then this ends up being the last 2 digits, because we got the 4, 8 and the 6, 9. We have 2 more digits to find in this box. We need a 2, and this 2 tells us that it has to go here. Cannot go here. And then the other digit we need is a 7. So we get the 2 and 7. That gives us this 3 and 7. That gives us this 3. This 7 gives us this 9 and 7, which gives us the 8, 4, and 9. That's going to finish this triple here and this triple here. So this gives us the 2, the 8, and the 4. This gives us the 6 and the 2. we get the 6 and the 9 and the 8 in this box. These are not 4s. We get our 4 down here, and then this is a single for the column. Just whatever digit's left. It's a 6. Over here, we got our 4 and our 9 looking at us. We got this 4 and this 9, so that ends up in 8. These are not 8s, leaving behind a 5-9 pair. Now we have a lot of things to look at. So I'm going to look at our fairly restricted houses. Like this box or this column, however you prefer it, only has 2 digits left. It's the same 2 digits. It's going to be a 8 and 9. That's not resolved, though. I want to look over here as well. We've got the 1, 2, 3. We need the 4 and the 7. This 7 here tells us the order. This is 4 and 7. That gives us, this 4 looks over, gives us this 8 and this 4, this 3 and this 6, and this 3. The reason I can place this 3 in the box, this can't be a 3 anymore because of this 3. And so now I look at my corner marks and I go, there's only one corner mark left that for 3, so I can just fill that, make it big. This for the row we can finish. This is a 9. That gives us this 5 and 9. And now I'm just going to finish up. It's all the same concept. So I need a 5 and an 8 here. Surprisingly not resolved. Oh, it is resolved. I just missed that this C is a 5 way down there. All right. So that's a 5. That's an 8. The 2 digits left here are 4, which goes here, and 7, which goes there. Let's do all of these pairs. So this pair is a 5 and 7. Okay. This pair here is a 6 and 9. So this 6 tells us the order, and that's going to give us a lot of stuff. 9 and 6, 8 and 9. I guess just those. We know we need the 2 because we have that corner marked. We also need I missed it on the first pass, 2 and 4. So this 4 tells us the order. 2 and 4 like that. Here, I'm looking at the columns here. We need a 1. That's not resolved. And we need a 8. So 1 and 8. So this 8 tells us it goes 1, 8. We now get this 5, 1 and 7, 5. And now we're down to 2 and 7. Last 2 digits of the puzzle, 2, 7. All right. So that is my methodology for solving the New York Times Hard. Hope it was helpful. And if you enjoyed this or found it helpful, then why not leave a like, subscribe, and a comment below.